Hello everyone. In this video content, we will learn how we can install the Tensorflow on a Raspberry Pi 4 Model B and run an object model example with this. All the examples and all the related and necessary commands are available in the link below the video. I used an image as a Raspbian Buster desktop. First, update your Raspberry Pi from UI or from the command line with an apt-get update command. I prefer the UI site. Just next and next. Then skip the Wi-Fi. I connect with the Ethernet cable. You need an Ethernet connection. It will take some time to update the software. After updating the system, you can reboot your system, you can reboot your Raspberry Pi, or you just log off and log in. Before that, be sure you turn on your Pi camera, because in this content, in this example, we will use Raspberry Pi camera module V2. From the preferences, there is a Raspberry Pi configuration tool. From there, you can directly select the Raspberry Pi camera. From the interfaces, just enable the camera. Yeah, you can click later, then restart now. After login, create a file on the desktop. You can give a name whatever you want. In this example, I just given a TensorFlow Rasp. Then first, we install the environment for Python development. We create our dependencies in the specific location. To do that, we simply install a virtual environment. So as you see, we have to log in and log off and log in again. Yeah. After login, then go to this desktop and we create the file. Now we can run the command virtual environment and env. It says environment will be created. To go that environment, we use the source environment bin and activate. Then at the beginning of the command line, there is an env, which means it is okay, environment is created. So now we install some dependencies, necessary dependencies for this environment. You can find the command, the whole command, in the link below the video in the GitHub page that I will give you. Some of the dependencies you may have already, doesn't matter. It will take some time. We run some commands with sudo and some of them without sudo. It is important to set these files, these dependencies here. In your system, some dependencies can exist right now, but in this environment, it is better to install again for this environment. That will protect your dependencies against the operating system. If you break something, you can simply delete the environment or you can create again. So when you create a new example, like in your project, I don't know, you should run in the environment. Then I will show you right now. Now for we don't train anything right now. We install the trained models. That is the command, one of the command. I will give the some constant version for this. This version will work. Keras simply is deep learning models that are made available alongside the trained weights. This is also the same, the Keras applications. Also, we need Keras processing in this version. Now we will install the PyBind, which is a lightweight header-only library that exposes C++ types in Python, or vice versa. And now install Hi5Py. The package is a Pythonic interface to the HDF5 binary data format that you can find in the internet. More information. These are used for the numerical data, some bunch of data, you know. It is necessary for an deep learning development. Very much it is used. Also 6 and VN mock dependencies we need. Let's install them. So we don't install the Tensorflow directly with the pipe tree. We will get from the related binaries, which is installed before, from the Lehentro Tensorflow on ARM. These are ready binaries that you can find for Raspberry Pi. The version right now 2.1.0, maybe in the next it will increase. You can check here. Install the wheel file directly. Then we will extract this. Actually, we installed TensorFlow directly with this wheel file. Then we have to log out again. This will be the, I think, the latest logout. Just call the wheel file. By the way, I use a touch screen. That is why the screen is a little bit big. The terminal is really big here. Doesn't matter, it will give the same result. It will take some time. After this, you will have the TensorFlow library in your environment. Now it is installed. We have to log out again. After login, just go to this file we just created before in the desktop. Then go inside an environment, your environment, with source command. Now let's try the import the TensorFlow. We will wait a little bit. And yes, if there is no problem, then you just install the TensorFlow. It's good. Now we will install the related files with our OpenCV. OpenCV is also necessary for object detection to draw the things. Before, there are some dependencies like a pillow, then a Jupyter and Matplotlib we can use later, in the later tutorials also. and also another dependencies for our environment. Now install the Python, so OpenCV Python. When you try to import it, you will get an error. If you get this error, then atomic fetch add error, you should install OpenCV contrib Python dependency as a version of 4.1.0.25. Then you will not have this error anymore after installation. Let's try to import OpenCV with CV2. Yes, it's installed and we can import. There's no problem. So now we will install the protocol buffer compiler. The data we will use for object detection, actually from the model we will install, it's stored in a way in the protocol buffers. Can check the version with proto-C version, then you will see the version here. Now we will install the TensorFlow models from the model garden. This repository is actually a little bit old, so we should change some definitions, some libraries according to our new TensorFlow 2.0 we installed. Now we should export the Python path. Also, we should add the bashrc with a sudo nano at the end of the file. You can add. If you reboot the device, you shouldn't worry about exporting this path. That is why we add this path to the bashrc. Now this is important. Go to the research file, research directory, models and research, then compile the protocol files, the proto files, as a Python version. That means your Python libraries, your Python programs can understand this protocol files, the proto files. You can check if you want. There are, as you see, just print the matcher proto file. There are datas. Their structures are inside. We use these informations. So go to the, compile proto-C and object detection protos.proto as a Python out. It's important to compile here. So in C, there are files with an extension py. That is the reason we install the proto compiler. So go to the object detection directory. You should stay there. Now install the model for an object detection that is trained before. It already exists. We shouldn't care the training right now. In the next tutorials I will show you how we can train our data. After installation, extract the file, the tar file, here in an object detection directory. Now install Python 3 PyCamera for this environment. But it's wrong to type. It should be PyCamera only. And we have to install the matplotlib and a pillow. Then get the example for an object detection and the link. You can find the link below the video also. Then I will update this example in the next. Be sure your PyCamera is enabled and is connected to your board, otherwise it will not work. When you run this example after getting the Python file, you will get an error because of the Tensorflow library. Protocol buffers is a method of serializing to make it data suitable and our example trained data is stored in that way. So only one line. Have to install this protocol file, protocol compiler. They are actually compile the data in the label for the Python util. Python. just go to there 138 as a line. Yeah, then change and actually add an IO. That is all here. And TF IOG file and path. That is the thing that we should change. Then Control X and Y. Then run the example with Python 3. You should wait a little bit here. It will take some time. And voila, you get your object detection example. It's working with the TensorFlow and the latest version actually. So that is all for me guys here, and I will prepare more tutorial about this and how we train our data for an deep learning, then more advanced tutorial about an object detection. So see you again. Bye.